Hi, welcome to the video for topic 1 vectors. In the first lesson, you will learn about the introduction of vectors. This video will explain the first part of scalar and vector quantities and the second part of the definition of a vector. Let's start with the first part.
Quantity by just mentioning its magnitude, that is, its amount or its size. For example, the mass of an object is given by a numerical value. The size of an object, that is, its area or volume, can be described just by a number. Similarly, speed, distance, temperature, etc. are quantities which can be completely described just by a numerical value. Such quantities are called scalar quantities. But sometimes, to completely describe a quantity, we need to specify its direction too along with its magnitude. For example, let's say you want to throw a ball towards your friend. For this, you not only have to decide how hard you have to throw the ball, but also in which direction you have to throw it. That is, how much force to apply and in which direction. Another example is wind. To describe the wind flowing at a place, we need to specify its speed and the direction in which it's flowing. The speed of an object along with the direction it's moving in is called its velocity. So here we can say that the velocity of the wind at this place is 30 km per hour in the northeast direction. This means that the magnitude of the wind's velocity is 30 km per hour and its direction is northeast. Such quantities which are completely described by its magnitude and its direction are called vector quantities. In mathematics and physics, you will encounter many vector quantities like this. Some more examples of vector quantities are displacement, acceleration, momentum, and so on. In this video and the upcoming ones, we will understand mathematically what vector quantities are.
We continue with the second part of the definitions of a vector.
Let's get started. Mathematically, a quantity that has magnitude as well as direction is called a vector. Let's consider one abstract example of it. Tell me, is a line segment a vector? No, right? A line segment has only magnitude, that is, length, but no direction. Now let's say we specify a direction for this line segment by an arrowhead. This means that the line segment is now directed from A to B. So let's call it a directed line segment. So now we have a magnitude and a direction for this directed line segment. Therefore, we can say that the directed line segment is a vector. We denote it as this. It's called vector AB. The arrow above the letters tells us that they represent a vector. The point A from where the vector AB starts is called its initial point, and the point B where it ends is called its terminal point. The distance between the initial and the terminal points of a vector is called the magnitude or the length of the vector. It's denoted as this, and the arrowhead indicates the direction of the vector. We know that for a line segment, we can show the direction in two ways. So here, instead of this, if we draw an arrowhead like this, then we can say that the line segment is directed for B to A. And thus, we get another vector BA, whose initial point is B and the terminal point is A. It has the same magnitude as vector AB, but is directed in the opposite direction. Usually, to denote a vector, we also use one more notation. Instead of this, we can denote a vector by a lowercase letter with an arrow above it. So this is a vector A with magnitude denoted as this, and this is vector B with magnitude denoted as this. Thus, we see that a directed line segment, which is a simple mathematical entity, is a vector. Now, to represent any vector quantity, we have to state its magnitude and its direction. Hence, to represent it geometrically, we usually use a directed line segment.
Stay tuned for the next video to continue our lesson.